Okay, so we're still in the Math 1 book, page 61, numbers 7 through 12, and we are adding and subtracting polynomials. When you're adding and subtracting polynomials, the main thing that you have to keep in mind is that all you're doing is adding or subtracting like terms. Another thing that you got to know is how to use parentheses. For example, in number 7, really there is no need for parentheses in this entire problem, but what it's trying to say is that this is a polynomial and this is a polynomial and we should add them. So, but really what happens is, since there is no negative sign out here, there's no positive, there's no a coefficient out here that you would have to distribute through, so really this question can be rewritten without any parentheses at all, and it's actually the same exact question. So that's what I would first tell you to do, is to write the question without parentheses. And then all you have to do is look for the things that you can add together that look the same. For example, this 3z squared and the 2z squared, those are going to be added together to make 5z squared. Also, you have a z, a positive 1z, and a positive 2z. I'll highlight that sign also. So that's 3z. And then you have negative 4. Negative 4, that negative sign is important, and also negative 3. Well, what would you get if you took negative 4 and subtracted negative 3 more? Now remember that these have the same exact signs, so when you have the same signs, you add their absolute values. So what's 4 plus 3? 7. So this one is minus 7 due to the fact that you have a minus sign here and a minus sign here. So this is actually your final answer. All you had to do there was add like terms. So let's move a little bit quicker on the next couple. 8c squared minus 4c plus 1 plus negative 3c squared plus c plus 5. Now, one thing that I don't typically like to write is a plus negative. I know they tell you to do that when you're getting used to subtraction, but in the 9th grade we're probably going to go ahead and assume that we are used to subtraction. So plus a minus is just going to be a minus. So 8c squared minus 4c plus 1 minus 3c squared plus c plus 5. And then you look for the things that look exactly alike, and basically the c squareds look the same. Okay, that's what you're looking for. You see that the so 8c squared minus 3c squared, 5c squared. And then you have negative 4c and positive c. So those have different signs, so that means you subtract. What's 4 minus 1? It's 3. And this one is going to be negative 3 due to the fact that the negative 4 is a bigger number than that positive 1. It has a bigger absolute value. So negative 3c, and then finally you add the 1 and the 5, you get 6. There you have it. Let's keep adding. 2x squared plus 5x minus 1 plus x squared minus 5x plus 7. This time I'm not going to use a highlighter because I think you're getting used to it. So 2x squared and x squared makes 3x squared. 5x and negative 5x makes 0x. Negative 1 plus 7 makes positive 6. Now, do you think I should leave the 0x there? And the answer is no. You're probably not going to leave that. People don't typically write all the zeros that they can write. Okay, the only time you'll necessarily have to write a zero is when a zero is next to an equal sign. That's one of the only times that you'll actually have to account for a zero being in a problem. But in this kind of question, we're going to say 3x squared plus 6 and leave that answer. That is our final answer. Okay? Alright, number 10. We have finally arrived at a subtraction problem. So I'm going to tell you when you need the parentheses. Okay? This first polynomial, you actually don't need the parentheses around it because, again, it is based off the first explanation. All you have is a positive 1 out here, and when you multiply a positive 1 throughout everything, it doesn't change the polynomial at all. However, this right here, this minus sign in front of this polynomial, means that we're actually going to be subtracting every term on the inside there. So, as a student, what I typically did growing up was I changed that negative sign, change it into a plus. And then I go all the way through here and I change every single sign that I see. Now this is a sign though. This says positive 4, okay? Positive 4b squared. So I have to change that to a negative. I have to change this one to a negative, and I'm going to change this one to a negative. And that's typically how I did it growing up. Now I'm pretty good at just saying that I'm going to distribute a -1, and I just change all their signs in my second step. But here's what we have. We have plus -4b squared. And remember, when I have to write this plus -4b squared, that I don't typically write a plus and a minus next to each other. I know that we did that in middle school probably when we were just getting used to adding negatives, but I'm just going to call it minus, okay? So this is 2 minus 4b squared minus 5b minus 1. And then you look for the like terms. 10b squared minus 4b squared is 6b squared. 3b minus 5b, different signs, so subtract. I immediately think of 2, but what kind of 2? Is it a positive or a negative? You're going to say -2 because the absolute value of 5 is bigger than that of 3. So you're going to say minus 2b and then plus 1. Circle that as our final answer. The way I wrote this problem, this is a minus sign here. Okay. Now the parentheses out front, this first one, it still doesn't need to be in parentheses really. They just wrote it like that so you would understand that I'm adding two polynomials. Okay. So from here you have a minus sign, and remember what I like to do is I like to change every sign like this. Some teachers like to just draw a sign like the distribution sign, and it is a distribution. However, the problem with that is that folks forget to distribute it to the first term. So right here it's minus m and then minus 2. Okay? So so that's what we're going to write. Minus m minus 2. Okay? So you have negative 4m squared. It's not matched up with anything. In other words, there isn't another m squared in here, so I don't have to worry about adding anything to it. but there is a 3m, a positive 3m, and a negative m. That gives me positive 2m, and then minus 3. And finally, a 3m plus 4 doesn't need a parentheses, but I do need to distribute that negative. Okay? Here, here, and here. So, minus 2m squared. A negative and a negative would make a positive, so that's why I'm going to write a plus 6m. And a negative times a positive gives you a negative, negative 5. So, what I notice is that there's a negative 2m squared, but there's no other m squareds in here. But I'm going to write the negative 2m squared at the very front of the problem, because in some of the other exercises in the book it asks you to rewrite the polynomials from highest degree to low, so that the exponents decrease from left to right, and that's what we're going to do here. We're going to make sure that the exponents decrease from left to right. In other words, the highest exponent goes to the far left, and then the next one will come next. So it looks like a 3m and 6m come next. That's 9m. And then 4 and negative 5 would make negative 1. So that's it for exercises 7